Good morning students, welcome to Swapna physics classes. In this lecture I am going to explain you coupling schemes. As I said in our last class, I am going to explain you coupling schemes. Just a minute, I just want to check my video and audio clarity. Give me a minute, that's it. Good morning Rajesh, good morning Mamlu. Hi Padma, good morning everyone. Thank you for joining my live classes. Is my audio and video clear? Is my audio and video clear? Please write in the comment section, please. In our last class, we had discussed about the angle, how to find out the angle between LS, LJ and SS. Sorry, SJ. The angle between LS, LJ and SJ. These are the angular momentums, right? Orbital angular momentum and spin angular momentum, right? And J is the total orbital angular momentum. And I asked you to solve the angle between LJ and SJ, right? I had solved for LS, right? I had solved for L and S, the angle between L and S. And this is your work. Did you do your work? Write in the comment section. Please try to complete your work on daily itself, day by day. आज का वर्क आज ही खत्म करना है. Don't postpone your works. Okay, and coupling schemes. Coming to our today's topic, coupling schemes. Coupling is nothing but interaction. Okay, interaction between spin angular momentum, interaction between orbital angular momentum, and interaction between total orbital angular momentum. And these coupling schemes are of two types, LS coupling and JJ coupling. Good morning everyone. Good morning Nagaraju, good morning Shiva. Is my voice clear or not? You just please write in the comment section. Yeah. So coming to LS coupling, this LS coupling is will occur in lighter atoms. LS coupling occurs in lighter atoms and JJ coupling occurs in heavier atoms. And these coupling schemes are of again divided into SS coupling, LL coupling and SL coupling. In LS coupling, that is orbital and spin angular momentum coupling. Okay, if this is the direction of the J bar, that is total orbital angular momentum for a single electron, and if this is the orientation or motion of this spin angular momentum, and this is the motion or momentum of the orbital angular momentum. Okay, then the coupling or interaction between L and S will be LS coupling, and again in LS coupling we are having SS coupling, that is orbital coupling for electron. LS coupling for atom and orbital coupling for electron. Sorry, spin orbital. This is spin angular momentum. Sorry, I'm really sorry. Spin angular momentum coupling, orbital coupling, and spin and orbital coupling. And JJ coupling takes place in heavier atoms. And in this coupling also we will having LS coupling, SS coupling, and LL coupling. And coming to LS coupling, here the spin angular momentum, and orbital angular momentum, orbital angular momentum interactions will be stronger than the orbital and spin angular momentum interactions. Okay, here SS and L interaction will be stronger than SL. And coming to JJ coupling, here spin and orbital interactions will be stronger than this SS and LL coupling. So you have to remember these points. These are theory questions. These are theory questions for you or set exams or DL and JL examinations. Okay, and coming to a example, I will give you an example. Okay, coming to spin orbit coupling, that is LS coupling. This is also known as Russell-Sunders coupling. Russell-Sunders coupling, and in this coupling, spin-spin interaction is stronger than orbital and spin interactions. Okay, spin-spin interaction is stronger as spin angular momentum of individual optical electrons combines to give spin angular momentum. Okay, for example, if we have two electrons, the spin angular momentum of one electron and spin angular momentum of second electron will combine to give total orbital angular momentum, total orbital spin angular momentum. Okay, this is the example I had given for two electrons. For two electrons, S1 will be 1 by 2, S2 will be 1 by 2. Okay, how to represent the spin angular momentum? It is 1 by 2 and 1 by 2. Okay, if we have two electrons, for one electron it will be 1 by 2, and for second electron also it will be 1 by 2. Then you have to combine both these. S is equal to S1 plus S2, that will be 1 by 2, 1 by 2, 1 by 2 plus 1 by 2. Therefore, this total spin angular momentum will be equal to 1. Okay, so here, for example, one more example I want to give you. If I have two subshells and three electrons, right? And if the two electrons are antiparallel to each other, that means they are bonded to each other. We have to not calculate for these bonded electrons. We have to calculate for the valence electron, that is individual optical electrons. Okay, the spin angular momentum of individual optical electrons are combined to form total spin angular momentum, capital S. Okay, and for electrons I am taking small letters, small s, small l, small j, and for atoms I will take capital letters, capital S, capital L, capital J. I had told you in our last class itself, right? And this S value can take values from mod S1 plus S2 to mod S1 minus S2 for electrons. Okay, and coming to one more example, for 3 electrons, what will be the capital S? You have to calculate, it is your work. I will do a little. For 3 electrons, S1 is 1 by 2, S2 is 1 by 2, S3 is 1 by 2. These are unbonded electrons. These are not bonded to each other. Okay. Then for this, calculate capital S. Capital S values will be from mod of S1 plus S2 to mod of S1 minus S2. Okay, you have to calculate this one. And coming to our next topic, so for 3 electrons you will be able to find out this capital S value. You will be able to. If we have 4 electrons, 5 electrons and 9, 10 electrons, so how will you find out the capital S value? Initially you have to do the sum for first 2 electrons, right? And again you have to do the sum for the result of these first 2 electrons and the third one. Okay, and if you have 4th electron, you have to add this one to this 4th electron. It will be little harder to find out. Therefore, I will give you a trick to find out the S value. So for n even electrons, if you have even number of electrons, then the s values will be 0, 1, 2, so on n by 2. Okay, and for n odd electrons, if you have odd electrons, then the s value will be 1 by 2, 3 by 2. This will be 3 by 2, 5 by 2, and so on n by 2. Okay, you have to remember this, as this is very important trick. Good morning, Juluri Krishna. Good morning, Rajesh. Thank you for joining my live. Thank you so much. And for 4 electrons, if you have 4 electrons, n is equal to 4, and this is the even number. As this is even number, you have to use this first trick. Okay, s can take values from 0 to n by 2. So you have to find n by 2 initially, that is 4 by 2 will be 2. So therefore s values will be 0, 1, 2. 0 to n by 2 for even. Also a strong interaction, and this orbit-orbit interaction is also a strong interaction for LS coupling. Okay, so the strong interaction between orbital angular momentums of individual optical electrons gives you the orbital angular momentum, total orbital angular momentum, and it will be equal to L1 plus L2 plus and so on. And the modulus of this angular momentum is h cross into square root of L into L plus 1. This is solved in our last class. This equation is solved in our last class. Is it clear? Good morning, way to success. Good morning, SFFG. Good morning. Thank you for joining my live. Is there any disturbance in my live class? That means is the video and audio is clear? Just please write in the comment section. Yes. And the L values, L can take values from modulus of L1 plus L2 to modulus of L1 to L1 minus L2. L1 plus L2 to L1 minus L2 modulus. You have to take modulus. For example, we have 3p 3d configuration. 3p 3d configuration. What is this configuration? Actually, the electrons. This is the configuration where the electrons will live. This is the maximum probability to find out the electrons. These shells, in these shells you will find out the electrons. There is a probability to find out the electrons in these shells. Okay, and for 3p 3d configuration, as we know, L values are from 0, 1, 2, so on n minus 1. 0 can be represented with the small s, 1 is p, 2 is d, and so on, right? So for L1 here for 3p 3d configuration, for p orbital L1 will be equal to 1. See here, L is 1, and for 3d configuration for d orbital L value is 2. Therefore L2 is 2. And now the values of L will be modulus of L1 plus L2 to modulus of L1 minus L2. Therefore L values will be equal to L1 plus L2. This is 2 plus 1 is 3, comma L1 minus L2, that is 2 minus 1 is 1. In between we have 2. So L1 values are 1, 2, 3. L values are 1, 2, 3 for 3p 3d configuration, and your work is to find out the total orbital angular momentum. That is for orbit interaction, you have to find out the L value. It is your work for 2p 3p 3d configurations. Okay, 2p 3p 3d configurations. And coming to spin orbit interaction. Good morning. Thank you for joining my live. So for spin orbit interaction, this is a weaker interaction. For LS coupling, spin orbit interaction is a weaker interaction. So why it is weaker? Why? Just because see here, LS coupling takes place in lighter atoms. As I told you, LS coupling takes place in lighter atoms. That means the electrons are very much close to the nucleus. Okay, so if the electrons are very much close to this nucleus, that means electrons lies in, that means the optical electrons, individual optical electrons will lies in ground state or first orbit state, for example. Okay, what happens here? The energy between the nucleus and the electrons will be stronger. Okay, so initially the spin of both the electrons in subshells, what happened? If I have an orbit in subshells, what happens? If I have two electrons, which are not bonded to each other, so there will be a strong interaction, spin interaction between these two electrons, and orbital interaction between these two electrons. Okay, if I have electrons into different orbits, then there will be a strong interaction of spin orbit interaction. In this case, you will have SS and LL interactions. These interactions are stronger, and in this case, spin orbit interactions will be stronger. For LS coupling, spin orbit interaction is weaker interaction, and the angular momentum, orbital angular momentum and spin angular momentum gives you the combination of orbital angular momentum and spin angular momentum gives you the total orbital angular momentum. So there is no need to find out the spin orbit interaction, the configuration for spin orbit interaction, and we will go for JJ coupling. In JJ coupling, we will find out the spin orbit interaction. Okay, as a spin interaction and orbit interactions are weaker, we are neglecting these types of interaction in JJ coupling, and we will go for spin orbit interaction. Sandhya, good morning Sandhya, thank you for joining. Good morning Rajesh, thank you for joining my live. And coming to spin orbit interaction, spin angular momentum and orbital angular momentum. Spin angular momentum and orbital angular momentum combines to give the total orbital angular momentum, that is J equals to L plus S. J bar Q is equal to L bar plus S bar. And coming to the example, how to find out this J value? J value? I will give you a trick to solve this J value. Okay, for 4P 4D configuration, L1 is 1 and L2 is 2. For P, L is equal to 1. For D, L is equal to 2. So if you combine and you solve for L value, L can take values from modulus of L1 plus L2 to modulus of L1 minus L2, right? And if you solve for L, you will have the values of L as 3, 2, 1 or 1, 2, 3. And for 2 electrons, here we have 1 electron and here also we have 1 electron, therefore for S1 it will be 1 by 2, S2 will be 1 by 2, and if you solve for capital S, you will have 0 and 1. Okay, you have to solve this, and I will give you a trick to find out the J values. Okay, this is the way to find out the J values. I am taking L values in this row, in column, and S value in row. Okay, that is L values are 1, 2, 3 I am taking here, and S values 0 and 1 I am taking here. Okay, yes. And now you just add these values. 0 plus 1 is 1. Okay, 1 minus 0 is 1. And 0 plus 2 is 2. 2 minus 0 is 2. 3 plus 0 is 3. 3 minus 0 is also 3. And here 1 plus 1. You have to add 1 plus 1 is 2. 1 minus 1 is 0. That means you left 1 in between, right? And 2 plus 1. You have to add here. Okay, you have to add. I'm adding 2 with 1. Okay, therefore 2 plus 1 is 3. 2 minus 1 is 1. We left with 2 in between. Okay, and 3 plus 1 is 4. 3 plus 1 is 4. 3 minus 1 is 2. 3 minus 1 is 2. We have 3 in between. So these are nothing but j values. So therefore you have the j values here for s equals to 0 and for s equals to 1. J values for s equals to 0 and s equals to 1 will be 1, 2, 3 and 0, 1, 2. This is for, just a minute, I will write in terms of spectral terms. Spectral terms and I explain. Yes, I will explain you the spectral terms. Don't worry. So for L equals to 1, it will be P. For L equals to 2, it will be D. For L equals to 3, it will be F. S, P, D, F. S equals to 0. L value. For 0, it will be S. For 0, L value. Okay. So here we will be having P1. P1. So before that, you have to know how to write the spectral terms. How to write the spectral terms. These will be the j values. Don't worry. After writing the spectral terms, I will help you to know. How to write these j values. So here this can be written as P1 D2 F3 base. Here you will be having j value. Base you will be having j. Okay, P210 D321 F432. Right, commas in between. Okay, and first of all you have to know how to write the spectral terms, then you will be able to understand this. Okay, so how to write the spectral term I will explain you. Spectral terms under LS coupling. Whenever the LS coupling takes place, how to write the spectral terms, let's see. So before that, you have to know that how many maximum number of electrons will be filled in subshells. So subshells lo manam maximum any electrons fill up cheyochu. Okay, the maximum number of electrons in a closed subshell will consist of 2 into TL plus 1. This is very important point. You have to remember this. Okay. So for example, I have S, P, D, F and so on subshells. For these subshells, for S subshell, the maximum number of electrons will be 2L plus 1. 2L plus 1. So for S equals to, for S subshell, L value will be 0. For P, it will be 1. For D, it will be 2. And F, it will be 3. S, P, D, F. L values will be 0, 1, 2 and 3. Okay, so 2L plus 1. For S subshell, just substitute L value in this equation. Therefore, 2 into 0 will be 0. You have here 1. 2 into 1 will be 2. So, maximum 2 electrons will be filled in S subshell. And in P subshell, if you substitute 1 in this equation, 2 into 1 will be 2 plus 1, 3. 3 to just 6. Maximum 6 number of 6 electrons will be filled in P subshell, and 10 electrons in D subshell, 14 in F subshell, and so on. Okay, maximum number of electrons to be filled in a closed subshell will be 2L plus 1. You have to remember this. Okay, and for a closed subshell, the spectral term will be 1s0. Only one spectral term you will be having. I will explain this spectral term for understanding this. Okay, how to write a spectral term and what is a spectral term? Spectral term is nothing but the probability of finding of the electron. Okay, where the electron in an atom is more probably live, and it is a probability of finding of the electron, right? And it can be determined as n into L. In base you have to write J, and in superfix you have to write 2s plus 1 P power P. P is the parity here, where n is the orbital quantum number. 2s plus 1 is the multiplicity, and P is the parity, and L is the orbital. L is the orbital quantum number. Just a minute. N is the principal quantum number, and L is the orbital quantum number, and J is the total orbital angular momentum. If you take small l, it will be orbital quantum number. Here we have capital L, it will be the orbital quantum number, orbital angular momentum, and S is the spin angular momentum, Okay, what is multiplicity here? 2s plus 1 gives you the fine spectrum of the atom. Okay, for example, if S value is equal to 0, that therefore 2s plus 1 will be equal to 1. Therefore, you will be having one line in the spectrum, only one line for S value equals to 0. For S value equals to 1, therefore 2s plus 1 will be equal to 3. That means you will be having 3 lines in the spectrum. Okay, multiplicity gives the number of lines in a spectrum. Okay, and this is the way to write the spectral terms. And see, in a closed subshells, for a closed subshells you will be having only one spectral term. Here this 2s plus 1 value will be equal to 1, and J value is equal to 0. And L value is also equal to 0. In this case. So for a closed subshell, that is S power 2, P power 6, D power 10, and F power 14, and so on, the spectral term will be 1s0. It is very important. This might be asked in your examination also, for set JLDL examinations. Okay, right. This is about the spectral term, determination of spectral term. And coming to I want to give you one example. For P1D1 configuration, that means you are having 2 electrons here. In this case, how to write a spectral term? Let's see. For PD configuration, L1 is equal to 1, L2 equals to 2 here, and here S1 is equal to 1 by 2, and here S2 is equal to 1 by 2. Okay, and from here L1 and L2 values you will be able to find capital L. It will be equal to 2 plus 1 is 3, and 2 minus 1 is 1. Therefore you left with 1. Okay, L values will be 3, 2, 1, and from here S values will be 1 by 2 plus 1 by 2 is 1. 1 by 2 minus 1 by 2 will be 0, 0 comma 1. and using this trick you will be able to find out the J values and the spectral terms. Okay, let's see. L values are 1, 2, 3 and L values are 0, 1, 0, 1. So here 0 plus 1 is 1 and 0 minus 1 is also 1. Therefore you are having 1, 2, 3 here. 1 plus 1 is 2. 1 minus 1 is 0. So here values are 0, 1, 2. 2 plus 1 is 3. 2 minus 1 is 1. Therefore here you will be having 1, 2, 3. And here 3 plus 1 is 4. 3 minus 1 is 2. Here you will be having 2, 3 and 4. So how to write the spectral terms using these J values? So for S equals to 0, J values will be 1, 2, 3. For S equals to 1, J values will be 2, 1, 0, 2, 3, 1, 2, 3 and 2, 3, 4. Okay. Good morning Poshala Suresh and good morning Praveen. Good morning Srilata. Good morning Sudhakar. Thank you so much for coming to my live. Thank you so much. And if you have any doubts regarding the topics whatever I'm teaching you, you can ask me in the comment section. And not only that, for PDFs, that means the questions will be posted in the Telegram. The questions related to these topics for practice purpose will be posted in my Telegram channel, and the link is provided in the channel about section. You just click on my channel name when if మీరు ఇప్పుడు వీడియో చూస్తున్నారు కదా నా లైవ్ క్లాస్, you will find the channel name below this video. You just click on it and go to the about section and you will find out the Telegram link there itself. You just click on the Telegram link and join my Telegram channel. Okay, so in my Telegram channel I will post the questions relating these topics on every Sunday for practice purpose. You can practice there. Okay, you can practice for your examination using those questions. Okay, yes. Okay, good morning everyone. You can ask your doubts, I will clear. Okay, so for these J values, and I'm going to write the spectral terms now. Okay, I will erase this. For PD configuration, this is for PD configuration. Okay, so before that we have to find out 2s plus 1, that is multiplicity. As we know that the spectral term can be written in terms in n into L J 2s plus 1 P. I am not going to discuss here about the parity. In our further class we will discuss about the parity. This is a way to write the spectral term. Here what about the multiplicity? For s equals to 0, multiplicity will be equal to 1, and for s equals to 1, multiplicity will be 3. Okay, so let's see. And here we don't know the n value. So I'm neglecting this. Okay, and I'm writing 2s plus 1. Here 1 into L is, this is PDF, right? For 1 we will be having L equals to 1, we will be having P. For L equals to 2 we will be having D, and for L equals to 3 it will be F. Okay, so I'm writing here for multiplicity 1. For multiplicity 1 I'm writing the spectral terms. 1 P 1 P 1. Okay, 1 P 1 comma 1 D 2 1 F 3. Okay, 1 F 3. And for multiplicity 3 and for multiplicity 3, these are the J values. Okay, so multiplicity 3 and L value 1 P 2 0 1 R 0 comma 1 comma 2. Multiplicity 3, L is D and J values are 1 2 3. And multiplicity 3 and L is F. Here J values are 2 3 4. So this can also be written as 3P0, 3P1, 3P2. And you write this as a 3D1, 3D2, 3D3. And here 3F2, 3F3, 3F4. To write the spectral terms. This is a way to write the spectral terms. And how many spectral terms we are having here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here we are having 12 spectral terms. Okay. And how to find out the number of spectral terms or the degeneracy? How to find out? I will explain this in our further class. Okay, let's see it. Before that, we have to find out the ground state spectral term. Okay, out of these, from these spectral terms, what will be the ground state spectral term? We have to find out that, and your work is to find out the possible spectral terms for n equals to 3. This is your work. Okay, and coming to the ground state spectral term, how to find out this ground state spectral term for NP4? That means we are having 4 electrons here. 4 electrons here. So you just find out the spectral term for NP4, and I will help you to find out the ground state spectral term. So for in this case here, this is for non-equivalent electrons. Non-equivalent means non-equivalent. This case is a non-equivalent case. That means here for non-equivalent electrons, L and N, either L or N are different. For equivalent case, N and L are same. Okay. For non-equivalent case, L and N are different. Okay. So here, if you check this one, PD, that means we are having 2 different subshells. That means L values will be different. Here L value is different. Okay, if you mention N value, that is for 2P 2D. For example, I am having 2P 2D. In this case, N values are same. N is equal to 2 only. But L is different. L is different in this case. Okay. So for non-equivalent case, either L or N are different. So for this type of configurations, we will solve the spectral terms in this way, using this trick. Using this trick, we will find out the spectral terms for non-equivalent case. And the ground state spectral term, how to find out the ground state spectral term? I will give you a trick here. Okay, if the subshell is filled less than half. Okay, for example, I'm having a subshell P and it is filled with 2 electrons. Actually, what are the maximum number of electrons to be filled in this P subshell? We can fill 6 electrons. Good morning, Tej. Bannu Tej, good morning. Thank you for coming to my live. So maximum number of electrons in P subshell can be filled are 6 electrons, but here I have 2 electrons. That means it is less than half filled. Okay, this subshell is less than half filled. Okay, so for less than half filled, you have to take lower J value. You have to take lower J value. If I have P4, that means this P subshell is filled with 4 electrons. That means more than half filled. Here this is more than half filled. Therefore, you have to take higher J value for ground state. So I am taking this example only. Okay. So I am taking this example. Here for P configuration, not this one, I will go with a different one. I'm taking P2 configuration. Here L value is equal to L value is equal to 1. L value is 1, and if I have N value is equal to 2, if I have N value 2, and if you write the spectral terms for this configuration, and we have 2 electrons here, 2 electrons, therefore S1 is 1 by 2, S2 is 1 by 2, and if you combine this here, if you combine, S values will be 1 comma 0. For 1 comma 0, you will be having the spectral terms P. 2s plus 1 will be here. For s equals to 1, 2s plus 1 will be 3. For s equals to 0, 2s plus 1 is 1. 2s plus 1 value is 1. So for s equals to 0, initially I am writing s equals to 0, 1p, and we have to find out the j value, right? For j value, I have to use this trick. L equals to 1 and s is 0 1 0 1. I'm adding this. 0 plus 1 is 1, 1 plus 1 is 2, 1 minus 1 is 0. So 2 1 0 j values. Okay, for s equals to 0, this multiplicity is 1, and have P, L is P, and J is 1. And for s equals to 1, multiplicity is 3, and P 2, 3p1, 3p0, 3p0. So here 2, we have 2 electrons. That means this P subshell is less than half filled. Therefore, we have to take lower J value. What is the lower J value we have here? 0. 0 is the lower J value. That means the ground state spectral term for 2p2 state will be 3p0. 3p0. Answer is 3p0. This is the ground state spectral term. In this way, you can find out the ground state spectral term using this trick for non-equivalent electrons. For non-equivalent means either N or N values will be different. Good morning, Simhadri. Good morning. Hi, madam. Hi, Simhadri. And coming for the case for equivalent electrons, that means both N and N values are same. For example, sorry, here in this example, N and L are different. Okay, sorry. For equivalent case, So give me one equivalent example. I'm taking 2D. In this case, I'm taking 3 electrons. 2D3. Can I take? Or else, yeah, 2D3. N is equals to 2. L is equals to 2. Equivalent, right? L value is 2, N is 2. And it is filled with 3 electrons. That means S1 is 1 by 2. S2 is 1 by 2. S3 is 1 by 2. Okay, for odd number of electrons, S value will be N by 2 from 1 by 2 to 1 by 2 to N by 2. So I have 3 electrons. So S values will be 1 by 2 and 3 by 2. 1 by 2 and 3 by 2. And yes, L equals to 2 and N is equals to 2. This is the 3 equivalent case. In this case, how to find out the lower energy level, lower energy spectral term, and how to find out the spectral, how to write the spectral terms. Let's see. So here I will take only 2 electrons. It will be easier for me to write. That's a way. Simple solve chain మాత్రమే నేను only 2 electrons తీసుకుంటాను ఇక్కడ. Example. So its values will be n by 2, 0 to n by 2, 0 to n by 2. Therefore S equals to 0. For 2 electrons it will be 2 by 2 will be 1. Okay, S values. And for 2 electrons I am considering. Okay, right. So for 2 electrons we will be having L values also 2, right? For 2 electrons. So as n equals to 2, L can take values from 0 to n minus 1. N minus 1. In previous scales also you have to correct this one. Here I have taken n equals to 2. That means L values are from 0 to n minus 1. 0 to n minus 1. You just correct this one and write the spectral terms. Okay. So here L values are 0. 2 minus 1 will be 1. 0 comma 1. Sorry. So no need of taking this n value. Just a minute, I'm really sorry, I'm little confused. If you take n value also, there is no need to take this into consideration. Why? Because L values from 0 to n minus 1 is for electrons, and here we are considering the atoms. Okay, for atoms we have to consider the LL interactions. LL interactions. Here, as we have 2 electrons will have LL interaction. That means L1 is 2 and L2 is also 2. So LL interactions. Here we have D 2 and 2. L1 is 2 and LT is also 2. So for LL interactions, L can take values from L1 plus L2 to L1 minus L2. Okay. So therefore L values are 2 plus 2 will be 4. L minus 2 minus 2 will be 0. Therefore we have 3, 2, 1. L values are 0, 1, 2, 3, 4. So for this configuration, we have to find out the spectral terms initially. L in this direction, S in this direction. S is 0, 1. L is 0, 1, 2, 3 and 4. So you just add up 0, 1, 2, 3, 4. And 1 plus 1 will be 1. 1 minus 1 is 0. So here we have 1. And not only that, here this is for equivalent case. So for equivalent case, what you have to do is in this series, that means for 2s plus 1 equals to 1, 2s plus 1 equals to 3. Here we have multiplicity. So for 1, that means for singlet, okay, 1 means a singlet, 3 means doublet or triplet, sorry, 3 means triplet, 1 means singlet, 3 means triplet. For singlet case, you have to remove the even one. You have to remove the even one. For triplet case, you have to remove the odd one. For equivalent, this is a trick actually. This is a trick. Keep it in a box. I am going to give you a trick to find out the spectral terms. How to write the spectral terms for equivalent electrons. That means in this case n and l values are same. This is an equivalent case of electrons. For this case, how to write the spectral terms and how to find out the ground state spectral term. I am going to explain you how to write the spectral terms and how to find out the ground state spectral term. Okay, we are going to do this now. Hi Rajesh, good morning. Good morning Ashok. Thank you for joining my live. Good morning Anil. Okay, so this is a trick actually for singlet state. Okay, if multiplicity value will be equal to 1, this will be called as a singlet state. If multiplicity value is 3, this is a triplet state. For triplet state, you have to remove the odd terms, and for singlet state, you have to remove the even terms. Okay, and now write the j values. Okay, here the j value will be 1 plus 1 is 2, 1 minus 1 is 0. So you have j values 0, 1, 2. And here in this case 3 plus 1 is 4, 3 minus 1 is 2. The j values will be 2, 3 and 4. So now you just write the spectral terms here. So for this will be S, P, D, F, G. S, P, D, F, G for L values. Now write the spectral terms. As this is a case for atoms, as I told you just now, we have to consider the capital letters. Atoms ఎందుకైనా ఇక్కడ అంటే మనకి ఇక్కడ 2 electrons ఉన్నాయి. 2 electrons ఎక్కడ ఉంటాయి? atom లోనే కదా ఉండేది. So you have to consider the capital letters. Now you just write the spectral term here. For singlet state, 1 S 0. Here 1 D 2, 1 G 4. Okay, this is a way to write spectral terms, right? Here you have multiplicity, here you have j value, here you will have L value. Okay, and here for triplet state 3 P 2 1 0, and here also this is for F 3 F 4 3 2. Okay, this is a way to write the spectral terms, and these are the spectral terms we are having for equivalent electrons. That is 1 S0, 1 D2, 1 Z4, 3p2, 3p1, 3p0. write separately. నేను ఇలా రాసానని చెప్పేసి మీరు కూడా ఇలాగే రాయకండి, జస్ట్ రైట్ సెపరేట్లీ. అండ్ 3p4 3f4 3f3 3f2. Okay, this is a way to write the spectral terms for equivalent case. And how to find out the ground state spectral term. Spectral term for equivalent electrons. How to find out the ground state spectral term. To find out this ground state spectral term, you have to follow the Hund's rule. So first of all, you have to go with the largest multiplicity. So first of all, first one you have to go with the largest multiplicity, that is 2s plus 1 value. So largest multiplicity ఉన్నదానికి ఏమవుతుందంటే తక్కువ ఎనర్జీ ఉంటుంది. ఓకే, దిస్ విల్ బి హ్యావింగ్ lower energy when comparing to the remaining spectral terms. Okay, next go for check for same s value, same s value. చూడండి, మనకి ఫర్ ఎగ్జాంపుల్ ఇక్కడ చూడండి లార్జెస్ట్ మల్టిప్లిసిటీ ఉన్న స్పెక్ట్రల్ టర్మ్స్ ఎన్ని ఉన్నాయి. ఫర్ 3 multiplicity you will be having 1 2 3 4 5 6 spectral terms. Out of these 6 spectral terms, what will be the ground state spectral term? We have to find out this. So after finding out this largest spectral term, what you have to check is check for s value. Okay, if s value is also same, what is s here? What is s here? Let's see. So check for largest L value, or not S here. So go for largest 2 plus S value, then after largest L value, go for largest N value. Okay, here in this case we are having largest L value is F. F is the largest L value. For higher multiplicity 3, we are having largest L value is F. Okay, so therefore this 3F will be the ground state spectral term, and for this 3F again the J values are 2, 3 and 4. Again we have 3 different J values, that is one is 2, one is 3 and the other is 4. Again we are having 3 different values. Then what will be the ground state spectral term? For these values, let's find out. If this F orbital, F subshell is half filled, that means lesser than half filled, then you have to go for lower J value, that means less than half filled. Okay, then you have to go for lower J value, or else if it is greater than half filled. ఇంతకుముందు యూజ్ చేసి అన్నాం కదా మనం ట్రిక్, అదే ట్రిక్ ఇక్కడ యూజ్ చేస్తాం. ఇఫ్ ఇట్ ఈస్ గ్రేటర్ దెన్ హాఫ్ ఫిల్, దెన్ యూ హ్యావ్ టు గో ఫర్ higher J value. Okay, yes. So in this example, what is the example we have taken? This is for equivalent case ND2. Yeah, ND2 is the example we had taken. So for ND2 and D2. Okay, up to 10 electrons you can be 10 maximum number of electrons can be filled in D subshell, right? So therefore that means these 2 electrons is lower, less than half filled. We can fill 10 electrons, up to 10 electrons. Here only 2 electrons is filled. That means here the D subshell is less than half filled. Therefore you have to go for lower J value. So in this case the lower J value is 2, right? So therefore lower spectral term, that means the ground state spectral term for ND2 is 3F2. So you have to follow this sequence to find out the ground state spectral term. Initially you have to find out the spectral terms for equivalent electrons. For equivalent electrons you have to find out these spectral terms using this trick. So for a singlet state you have to cancel out the even states, and for triplet state and triplet multiplicity you have to cancel out the odd one and write the spectral terms initially. Then after you have to go with the Hund's rule. First of all you have to go with the largest multiplicity. For largest multiplicity energy will be lower, and after that you go for largest L value. After in our previous example we are having 6 terms with the largest multiplicity. Okay, out of these 6 terms you have to eliminate few terms, right? So therefore you have to go for largest L value. Largest L value manaki emundi F, right? So here again we are having 3 more terms. Out of this you have to find out the ground state spectral term. For this what you have to do is follow the trick, that is if the subshell is less than half filled then you go with the lower J value. If it is greater than half filled you go with the higher J value. Then you will be able to find out the ground state spectral term for the given configuration. This is the whole process you have to follow, and for practice purpose tomorrow I will share a PDF in my Telegram channel. You just you just join my Telegram channel with the link which I had provided in about section, in my channel about section. Okay, you just join my Telegram channel. There you will find out the PDFs for the topics which I had taught in this week. Complete week lo meeku evaithe topics cover chesano aa topics ki meeku practice purpose kosam PDF provide chestanu Telegram channel lo. Okay, so you can solve those problems for practice purpose. And who didn't subscribe to my channel till now, please subscribe. Meanwhile please subscribe to my channel and like my lecture. మీరు నా లెక్చర్ని లైక్ చేస్తే లైక్ క్లిక్ చేయండి, లైక్ బటన్ క్లిక్ చేయండి. మీరు లైక్ బటన్ క్లిక్ చేయడం వల్ల నన్ను మోటివేట్ చేసిన వారు అవుతారు. అండ్ నాట్ ఓన్లీ దట్, ప్లీజ్ షేర్ విత్ యువర్ ఫ్రెండ్స్. నా లెక్చర్స్ ఎవరికైతే అవసరమని మీకు అనిపిస్తుందో వాళ్ళకి షేర్ చేయండి. ఇట్ విల్ బి హెల్ప్ఫుల్ ఫర్ దెమ్ టు క్లియర్ JL, DL set examinations as well as UGC GATE, UGC NET and CSIR NET examinations. Okay, in my next class I am going to explain fine spectrum. In fine spectrum we will cover Z-man effect and Stark effect and not only that, Stern-Gerlach experiment. Stern-Gerlach experiment. In our next class, we will going to learn fine spectrum and Stern-Gerlach experiments. Okay. And if you have any doubts, you just ask me in the comment section. Thank you so much for joining my live. Thank you so much. And here I will end our lecture. And in our next lecture, I will also give you this term value. How to find out a term value? What is a term value? Let's see. For fine structure spectrum, we will also find out the spectral terms. Okay, it's also a lengthy topic. It might take 1 hour to 1.5 hours. Good morning, Ramesh. Thank you for joining my live. So it might take 1.5 hours. So on Monday, I will try to complete atomic spectroscopy. On Monday or Tuesday, in 1 more or 2 more classes, we will going to complete atomic spectroscopy. And on Thursday, Tuesday or Wednesday, we will start molecular spectroscopy. So stay connected. If you have any doubts, you can ask me in the comment section. Okay, thank you. Bye.